Hi folks, we're going to take a look at number 15 from page 460. So they give us the equation of this plane in vector form, and they name the y and z intercepts, points A and B, and they want us to determine the equation that contains these 2 points. Okay, so the goal is to determine these 2 points, find the vector joining them, which will give us a direction vector, and then use one of the 2 points to write the equation of the line. Okay, so first thing we have to do is determine these points A and B. So A here is the y-intercept, so that means we're looking for a point that looks like 0, y, 0. So in other words, the x and z components are equal to 0, and that's what I'm going to use to create a system of equations, because we notice here the equation of a plane has 2 parameters. Okay, so when we write out the components of any particular point, there's only 2 unknowns. Okay, so we're going to use these 2 equations. So let's start with x being equal to 0. Okay, so that's the x value. So the x value is given by 1 plus 1 times m. So 1 plus m plus 1 times n. So any point on the plane, the x component is given by this particular expression, and we want it know when it's equal to 0. And we need the z component to be equal to 0. So 0 is going to be equal to 3 plus 5m. Okay, and plus 3n. Okay, and now we have a system of 2 equations and 2 unknowns, so we can solve for m and n, and then from there determine what the y value must be. Okay, so 1 and 2, so let's multiply, I guess we'll multiply equation 1 by 3. So what do we have? We have 0 equals 3 plus 3m plus 3n. Let's subtract these 2. So 0 is equal to 3 minus 3 is 0, 5m minus 3m is 2m, and that's also equal to 0. So m is going to be equal to 0, and then we'll use equation 1 to find n. Okay, so 0 is equal to 1 plus 0 plus n, so I'm using that one there. So n is equal to negative 1. Okay, so now that I have the m and n values that make the x and z components 0, I can now use that to find y. So y is equal to, so remember, it's on the plane. The point we're looking for is on the plane. So it's 2 plus 2 times m. So 2 plus 2 times, well, m is just 0. So nothing interesting there. Plus, what do we have? Negative 1 times n. So negative 1 times n, and n was also negative 1. So 2 plus 1 is 3. So y is equal to 3. Okay, so our point A then is going to be the point 0, 3, 0. Okay, that's the y-intercept. Okay, so now we got to do the same thing for B. Okay, but now B is going to be the z-intercept, where the plane crosses the z-axis. So we're looking for a point of the form 0, 0, z. So I'll go a little faster now. So our first equation will just be the same as this one here, when x is 0, so 0 is equal to 1 plus m plus n. And our second equation now is going to be when y is equal to 0, so 2 plus 2m, okay, minus n. Okay, and that's actually nice because I can just add these 2 equations. So we get 0 equals 1 plus 2 is 3. And here m plus 2m is 3m. And of course that's just equal to 0. So m is equal to negative 1. And now I'll go back to equation 1 to find n. So we've got 0 equals 1 plus m is negative 1 plus n. And hey, those cancel out. And so n is equal to 0. Okay, so pretty nice. So now that I have m and n, I can now find the z value that corresponds to these parameter values. And what does that give me here? So that gives me 3 plus m is negative 1 times 5, okay, plus, well, n is 0 times 3. That just disappears anyways. So the z value here is 3 minus 5 is negative 2. Okay, so our second point is 0, 0, negative 2. Okay, so now I've got 2 points, and from this point here it's pretty straightforward because we just join these with a vector to find our direction vector. So I'll do this so that I'll go from B to A so that we get everything positive. So here we've got 0 minus 0 is 0, 3 minus 0 is 3, and 0 minus negative 2 is 2. So there's our direction vector, and choose either one of these 2 points. I'll choose 0, 3, 0 as my point P. And so the equation of my line is given by 0, 3, 0 plus t times 0, 3, 2. Okay, and here where t can be any value in the real number system. Okay, I guess the only thing to look for is see if they're asking anything particular. No, they just want to determine the equation of the line. So that would be a final answer. Now again, if you used 0, 0, negative 2 plus t times 0, 3, 2, that's perfect.